Hi, and welcome to the second tutorial of the pm4py tutorial series. In this tutorial, we'll be looking at importing a CSV file which contains event data, which we then subsequently want to analyze. My name is Sebastian van Zelst. I'm a researcher at both the Fraunhofer Institute for Applied Information Technology as well as the Process and Data Chair of the RWTH Aachen University, both located in Germany. To briefly recap what process mining is all about, several operational processes conducted primarily in businesses, they leave their digital traces in the information systems that these companies use. So think of processes executed in the logistics domain, the financial domain, the medical domain, online, retail, etc. Various processes executed by these different organizations active in those different fields. They leave digital footprints in their enterprise resource planning systems, etc. And the idea of process mining is to basically exploit that data. So a sort of definition that one could give is that process mining is all about obtaining knowledge of and also insights in processes by means of analyzing the event data that was generated during the execution of the aforementioned processes. And why we want to generate that knowledge and insights, obviously, is to be able to improve a process. So when we get a better understanding of how a process is executed within a company, this kind of is the first possibility to also try to improve it. So people that are more familiar with fields like business process management and those type of fields, in that type of fields, this knowledge and insights is often generated by interviewing employees, by interviewing the stakeholders of the company that are active in the process, like a process owner or just an employee that is doing a certain part of a process, by interviewing these people and on the basis of these interviews, trying to get an overview picture of what is going on in the process. And in process mining, the idea is basically that we try to do that on the basis of data. Now, as I indicated earlier in this tutorial, we will be specifically looking at importing a CSV file. So again, to sketch the idea of event data, we're going to take the example of that we're owning a company that is in the business of sending Christmas presents to their clients. And the idea is that we're specifically looking in a process towards a process that's executed in our warehouse. And if we do so if we extract a data set from our warehouse information system, that data set could look something like this. Needs to be said that obviously this is a simplified form of what is really out there in the data. But what we see here is a table containing 3 columns and a bunch of rows. And I'll briefly go through each column. Actually, I'll start at the middle column. So in the middle column, you see the column name is the activity column. And this implies that every row in that column records what activity has been performed for an instance of the process. And the specific instance of the process is, in this example, identified by the first column, this order ID. So for example, if we look at the first row, first column has an order ID value of 1233. That means that within our internal system, there has been a Christmas package that we've been sending to one of our clients with the internal order ID 1233. So whenever I see a recurring value 1233 in this table, I know that anything I see in the subsequent columns has something to do with that specific order. So if we look a bit closer in this specific table that I've been using in this example, we observe that not only the first, but also the last 2 rows in this table, they are related to a order with ID 1233. So the first row describes a create order activity, and it was executed, a little month before Christmas of 2019. Because it's been executed at the 2019th of November of 2019. 29th, I'm sorry. And in this case, we've chosen a European timestamp format. Now, if we go a bit further down the table and we look at the last two rows in this table, we see that there was also an item added to our Christmas present, and finally that order was submitted shortly after. And what's interesting is that if we look a bit closer, we see another reoccurrence of a order ID. So there's the order 1, 2, 3, 4 in this table. And we see a create order activity and an add item activity. If we look one row above the first highlighted row, the second row in this table, so the second row of this table is order ID 1, 2, 3, 2. There's a dispatch order activity, and that happened at 29 November of 2019 at 5:15. Again, it's European time format, 5:15 p.m. It is likely that in this case, the other activities that were performed for this order with ID 1232 have not been recorded in this event log somehow. Okay, so a little, let's say, differentiation with respect to terminology is each row in this table refers to an event. And such an event in this example carries information about an activity. So when I talk about an event, I talk about the occurrence of something in the context of an instance of a process, which is typically the occurrence of an activity. However, an activity is not the same as an event. For example, I can add multiple items to a specific order. Theoretically speaking, if someone orders 5 items, I will have 5 events representing the same add item activity. So an activity is something that happens, that can happen, that we can do, that we can perform, that we can execute. And an event in the context of process mining is typically the effective recording of such a happening. So that's the difference. So each row in this table describes an event or is an event. And events contain information such as which activity it relates to. And in some cases, events are even split up. So you have an event that signifies starting an activity, and another event signifies finishing an activity or suspending an activity, etc. So even though in this specific example that I'm showing you, you see an event capturing just the atomic occurrence of an activity, there's no specific duration. And obviously, I did that for the sake of simplicity, but there are various ways in which you can represent this event data in more detail. But this is something that we will treat in later tutorials. All right, so now I'm going to effectively show you how to import CSV files, and what I'm going to show you roughly follows our Getting Started page of the pm4py website. And we'll be using a process in this example that follows the behavior that you see in this slide. Now, if people are familiar with the business process modeling notation, then it's fairly easy to see what's going on. But if you're not, I will briefly sketch what's going on here, and probably we will devote a separate video on how to reason on graphically represented process models. So here I will briefly show you how you should interpret this picture. So what we see here is a graphical representation of what is supposed to happen in the process, of which I've collected some event data, which we will be using in this tutorial later. And how you should read this specific drawing in a way is we start basically always at the starting point, which is in this slide on the left-hand side in the circle represented by start. And all these squares with the rounded corners, they represent activities that we can perform. So as I said, it's an activity that we can perform. So if we ever see data, there will be events that capture the same activities that are registered in those boxes. So in this specific process that we've visualized or that we've drawn here, we observe that first activity is a register request, right? It's next to the start point. Then there's some other activities, namely the examine thoroughly, examine casually, check ticket, decide, reinitiate request, pay compensation, and reject request. Those are the activities that are part of our process. This is a example process that is also part of the seminal book of Wil van der Aalst on process mining. Apart from these boxes that contain the activities, there's a few squares, chevrons, diamonds, sorry, that they're also part of the picture next to the arrows. So the arrows indicate the flow, like the direction at which we should read this picture. So in this case, we go primarily from left to right. Sometimes we go up and down. And these diamonds, they basically in this picture can mean two different things. If I encounter a diamond that contains a cross in the middle, this means that I'm either splitting or merging, but I'm doing that in an exclusive way. So I'm either, if I have a diamond with an incoming, with a cross with an incoming edge, like the first diamond we see, next to register request, let me try to mark it. Yeah, there we go. This guy. So this has two incoming arcs, right? One register request, one reinitiate request. And since it's a diamond that has a cross inside, it means that we can either come from one of those. And in this specific example, if you look at the reinitiate request, obviously also from the name, we can observe that this somehow means that we're going to redo something. So another example of this type of diamonds are at the examination part. So here and here. So basically, what do we see here? When we go to the examination, we can either do a thorough or a casual exam, but we cannot do both at the same time. Again, because before we get there, if we just follow the arc, before we get there, we have this diamond with a cross inside, meaning you do either of these things, but not both. The same in the end, right? So again, here we have a diamond with a cross there and a diamond with a cross there. Basically, so what we can do at that position is we can either pay, we can reject the request, or we can reinitiate the request. And when we do that, we get back into this first diamond with the cross inside. So that's about the diamonds in this picture with the crosses. Now there's two diamonds which have a plus, and these diamonds basically represent the possibility, or actually the explicit presence of concurrency or parallelism. So that means that if we enter the first diamond with a plus, that means that from that point onward, the two outgoing branches, which are, I highlighted again, so the check ticket branch and the examination choice that we've seen before, those two branches are executed concurrently. That means that we execute both of these parts, but we can do that in arbitrary order. So that means in this picture that once you arrive, when you would walk over the arrows, once you arrive on this diamond with this plus, you basically have to split yourself in two because you're going to walk onto both outgoing arcs. And the same holds on the other side. Because you've split yourself into two, once you've done either the thorough or the casual examination and the ticket check, you'll have to merge yourself because you've split yourself at the previous concurrency point. So you're coming from two arcs into this diamond with a plus. So when you have a diamond with a plus, you always expect that you're basically walking over all its incoming arcs, and then you merge into one piece again. But if you then have multiple outgoing arcs, again, you're going to split yourself into multiple, you're going to walk all the branches at the same time. So you should be able to split yourself to be able to effectively walk over these branches. And if you encounter the diamond with the cross, then basically that means you pick one of the incoming or outgoing. You're either incoming from one point or you're outgoing one point. So when we then analyze this process with the information that I've just given you, we observe that we always first, when we start walking from the start, we encounter the register request. Right, we're walking and we encounter the register request activity. So we always start with a register request activity. Then we encounter the first choice point, and we're coming from the register request. So we merge onto our first choice point. Then we hit our first concurrency point here, and so we split up in both directions. So one half of us goes that way, the other half of us goes that way. Now, I hope that it's kind of clear that we have to perform this check ticket activity, and then we have to do either an examination, either thoroughly or casually. When we've done either the casual or a thorough examination, and we've also performed the check ticket, we merge onto this concurrency block here, after which a decision activity is made. And you see that again, after the decision activity, there's again a choice construct, an exclusive choice construct represented by a diamond with the cross inside, that guy. We either pay or reject. And if something went wrong, and this is of course a simplified example, an abstract example, if something went wrong, we reinitiate the request, which means that we have to check the ticket again and do an examination. And then again, we come up with a decision point, and then we either pay, reject request, or we do it again. So that's the process that we're following. And now if I have an event log that captures behavior that is described by this process model. And we're going to use that in the remainder of the tutorial to import it. For that, we're actually just using pandas. It's very easy. And to also calculate some basic statistics. So, different screen here. I've got a few files here. I've got running example CSV file, importing CSV file example 1, and importing CSV file example 2. So I'm going to execute those scripts, and we're going to see what happens. It's very important that you have installed pm4py using the installation guide that is on our website. So go to pm4py.org or pm4py.fit.fraunhofer.de. If you go to pm4py.org, you will be transferred to the other one and follow the installation instructions there. So I've done that. I've installed pm4py, and I've also created a virtual environment in Python to be able to run these different experiments. So first, what we're going to do is going to take a look into the running example script. I'm using Vim for that, which is just a Linux text command line text editor. Take some coffee during my one-shot tutorial. All right, so what do we see in our in this beautiful file? I'm going to try to make the screen a bit smaller for myself so that I can effectively read it. There we go. Oh. All right, so what do we see? We see, again, as I said, in this file, we basically see in the first row, we see what's very common in comma-separated values. We see the headers. So basically the column names that we will see in each row that is following the first line. So basically this CSV file is basically a text file representing a table. That's how you can look at it. First row represents basically column names. So we observe that there's a column, first column, that has the name case ID. Then the second column is an activity. The third column is a timestamp. So this should be very familiar because I've been also showing that in my previous my slides. Then furthermore, we have some costs and we have a resource. So that's a bit of more information. So if we look in the second row. So we see, by the way, that in the first row, we see that these names of these columns are constantly separated by a semicolon. So whenever we observe a semicolon in any row, that means that we go from one column to the other. And we always start with the case ID column. So if we look at the second row, we observe that there's a case ID column with value 3. So there is some case, a ticket, a compensation request. Remember that the process that I've shown you was about compensation request, where we see that the first activity is the register request activity. It's quite a while ago. It has been in 2010, so 2010, 30th of December. Bit of a weird date, but yeah. Again, European time format. So we see the first row that actually captures data, which is row number 2, represents an event or captures an event that shows us that activity register request was executed at the 30th of December 2010 at 14:32, which is 2:32 p.m. The +01:00 at the end of this timestamp is basically the time zone, represents a time zone, Central European time. Then we observe that that specific execution of that activity has had a cost somehow of 50, and it was executed by a resource named Pete. Now, if we go to row 3, which represents basically the second event in this specific data set, we observe that there is a examine casually activity executed by Mike. Cost quite some money, 400 euros or dollars, I don't know. And it's like roughly half an hour later with respect to the first register request. Because observe that also the third row represents an activity that is executed in context of case with ID 3. Then the next row number 4, is again an activity that has been performed in the context of case ID number 3, which is a check ticket by Ellen. So if we continue this, we see that after the check ticket, there's a decision being made, and then we observe that there's a reinitiate request activity executed for case number 3. Then there's a thorough examination, represented line 7. And if we go to line 8, we again see the check ticket. Remember that this is in line with the model that we've been discussing before, because we had to do an examination again and also ticket check when we decided to reinitiate the request. And then in line 9, there's a second decision, because obviously we also have to decide again. And then finally, a compensation payment is made. And that's all the events that are captured for the request with case ID number 3. If we look at the line 11 in this file, we observe another sequence of activities executed for another case. Namely, in this case, it's case ID 2. So we actually see that in this file, the ordering is definitely not on the value of the case ID. And there we see that in line 11, the first thing that happens is a register request, which is, as I said, is supposed to happen. Then we see a check ticket activity in line 12, casual examination, and then a decision. And in this case, there's no need to reinitiate the request, so compensation is paid, which we see in line 15. So this is basically an example of an event log. I will put a link to this same file in the description of this video so that you can also download this file and look at it yourself. It contains a few different cases. Another terminological thing that I would like to mention is that the sequence of activities described by these individual events is often referred to as a trace of events, or simply a trace. So these first 9 events, line 2 until line 10, they basically form the trace of activities that we can observe for a case identified by number 3, and then line 11 until line 15 represent another trace that is a trace of events that we can observe for case ID 2, etc., etc. So as I said, I will share a link to this file in the description of this video. Now, what I'm going to do is I'm going to go back to my folder. And what we're going to do is we're going to basically first load this file into pm4py. But the thing is, in pm4py, what we actually decided is we represent event log in a bunch of ways. And more about this can also be read in our Getting Started page on importing event data. We also decided to try to natively support CSV files. In some cases, it might be faster to transform a CSV file that you've imported to our own internal event log object, but in principle, you can use pandas data frames to represent your event data. And in this specific first tutorial, since we're talking about importing CSV files, that's what we will be primarily doing. So I'm going to show you the first example script that I have for you here. And it's fairly short, as you can see. And because we're only going to import CSV file, in this first example script, I'm not even using pm4py. So I'm importing the pandas library, which you have to have installed in your Python, whatever Python distribution you're running, and whether you're using Ancona or Minicona, you have to have it installed. The thing is, if you install pm4py, I think pandas is, of course, one of our primary requirements. So if you install pm4py, you get pandas as well. All right, so I'll go through the script and then we're going to run it. Fairly simple. The first row imports pandas, and the last two rows are basically a boilerplate code that actually makes sure that we are going to run the main function that is defined on line 4. Our function is called import CSV and has a one input variable called file path, which is the path to our file. Now, I've put this specific script in the same folder as I've been putting my running example.csv file. So I can basically write in my as my path, I can just write the file name in this case. So what do we do in this specific very simple script? We load the event log using the pandas.readCSV function. We give it the file path, and we indicate to pandas that we're using in this example a semicolon to separate the different columns. Then I want to know the number of events, and I want to know the number of cases. That's the first type of query that is somehow process mining knowledge. For this, again, I don't need to use pm4py for this. I can use native pandas for this. In the next example that I'll show you, we'll use a bit of pm4py's process mining specific functions. So to get the number of events, obviously, I just need to ask the length of the event log. That's right. This is the length of our table, basically. Because pandas automatically excludes the first line, which represents our header. And then the number of cases is basically simply taking the case ID column, taking the unique values, which generates a set of values from our table. That's what you see in line 7. And then taking the length of that. And again, I have the number of different cases that are represented in this table. And what I do in line 8, obviously, I print the number of events and the number of cases that I've just put in these two variables. So fairly easy script. And I'm going to run it right now. So again, I'm using a virtual environment, really advisable. What it's going to do, as I said, is going to import the CSV file that I've just shown you using pandas, and then it's going to count the number of events and the number of different cases that we have in our data set. And it does so by exploiting pandas specific functions. And the result of my script is shown in this in my terminal here. So the number of events is 42. And the different number of cases is 6. And if we again look at our file, then we see that there is a number of 43 lines, implying 42 events. And we see the values 4, 5, 6, 1, 2, 3 for the cases. So indeed, it seems that our script was correct. All right, now let's take a look at a second example, which is a bit more involved. So what I want to do now is I want to load this CSV file, but I want to specifically know, okay, which activities potentially start and which activities potentially end a process instance, right? So this is a more specific type of question because now we have to reason over the trace, right? We have to somehow know that, okay, we're now looking at process data, so it's a sequential data point. Actually, there's multiple rows in that table representing an instance of a process, and that number of rows per process instance can actually be different. And we have to then fetch the corresponding start and end activities that are there. So that's the first script where we're going to actually also use pm4py. All right, so what do we see here? We see a bit more than we saw in the first script. So what we see is in the first two lines, I'm now again importing the libraries that I need in the script. So first of all, again, I need pandas because I'm here going to use pandas to import my CSV file. And I'm importing the pm4py library. Again, the bottom two rows are just boilerplate to get this up and running. Now, first line of my import is again importing the file. So I see event log is pandas.read.csv, but I've added something. So what I've added is I've added a formatting of the data frame that I've just imported. So what do we see here? I'm on line number 7. I'm writing the event log. I'm reassigning the event log variable to a function that outputs another data frame, but it's a formatted data frame. And what does it do? This format data frame, you give it the event log, you give it the name of your case ID column, which in our example was case_ID. You give it also the name of the column that represents the activity, which in our event data was activity, and you give it the name of the column that represents the timestamp. That's the, let's say, the bare basics for this specific function, because what it does, it's translating these columns to a different column name so that any algorithm in pm4py can use a standardized column name. You do not necessarily need to do this. So every algorithm also has the option for you to specify, okay, what column is my activity, what column is my case, what column is my timestamp, or a lot of algorithms have this functionality. But if you do this, then natively you can toss around your event log everywhere. So in principle, I always advise to import a CSV file using pandas and then do this transformation function, or you can even plug in this formatting directly, of course, in your first import line by wrapping this around the pandas.read function. What is optional and very advisable is the last argument of our formatting here. That is this timestamp format parameter. So it's this time_st_format. So why is this advisable? And what does it do? So for people that are fairly familiar with timestamps, you probably know that you need to specify the format of your timestamp. So the way in which your timestamp is, your time data is represented, because it's possible in a variety of ways. Now, if you remember what I did in this, or what we have in this example event log, is we have timestamp format that first had a year, then it has a dash, then, or a minus sign basically, then we have a month, another dash, we have a date, we have a white space, then we have in a 24-hour format, because we use this 24-hour European style time format, we had hours, colon, minutes, colon, seconds, and then we had the offset that represented our time zone. And that's basically what you see in this specific string that I have for my time st underscore format parameter there. So this percentage y means this represents a year. So, then you will see a minus sign, and then you see the month, which is represented percentage m. Then you see a minus sign percentage d. Then you will see a space. Then you'll see a 24 hour, 24 colon, 24 minutes, colon, seconds. And the colon and the percentage z represents, then you'll see something like a plus and the number of hours, that is the time offset. So why is this advisable? That's the following thing. If you call this format function in pm4py, what pm4py is going to do is it's going to automatically parse the timestamps into date objects. And it's using pandas for this. However, pandas, what does this, it has an automated timestamp detection, which on the one hand is great. At the same time, you have to be aware, because it does that, it seems to do that on the basis of our experiments on a row by row basis. And this can lead to inconvenient situations where in some cases, the month and the day are actually swapped, right? So month and day, a month can never exceed 12, but if you have, for example, a date, let's say the 4th of March 2020, then sometimes pandas can swap that into the 3rd of April. So it can swap the month and day values if you do not specify it. So at the moment, what we do not have in pm4py is some sort of majority vote system where we basically check all the timestamps, do the automated detection, and then decide, okay, this is the majority of timestamp format, so we'll pick that. So if you know the explicit timestamp format of your data, it's very advisable to add it to the pm4py.formatDataFrame function. All right, then what we're going to do is we're going to exploit two basic utility functions of pm4py that run both on data frames or on our internal event log objects, that we will see in the next tutorial number 3. So there's a pm4py.getStartActivities and a pm4py.getEndActivities. And I guess what these functions do speaks for themselves. They will give you an overview, statistical overview of the activities that occur in this data set as the first activity to happen for a case, or respectively at the last activity to happen for a case. Yeah, and what I'll do at the end, so line 10 of this script, I'm going to print the result. So what I'm going to do is I'm going to call this script. So that's example number 2. I'm going to run it. And there we have the result. You see that the start activities value for the variable is well represented as a curly bracket, and then we see a string capturing register request and then a colon 6. So this is the visualization of a Python dictionary, which you can basically see as a map for those that have little experience in Python. This basically states that the value of the register request key is 6. So obviously this means in our example that there's 6 traces in this event data set that have register request as their first activity captured by an event. Then if we look at the end activities, we see that in 3 cases pay compensation was executed, and in 3 other cases reject request was executed. So as you can see, this function gives you a dictionary, and of course you can do fancy things on top. So if you would like to do some filtering, you can basically assume you have a big real event log and you put that in, and you get a wide variety of different start and end activities. For example, you can just try to learn a certain distribution, apply some outlier detection on top, and then create a subsection of start and end activities that you would like to consider as true start and end activities, and then you can consecutively filter your event data on only those cases that actually contain those start and end activities. which is something we will do in a subsequent tutorial. And that concludes this tutorial on importing CSV files. So basically, again, some introduction on, okay, what is event data and how to do this in pm4py. And the trick is, as you've seen right now, it's fairly little pm4py. It's a lot of pandas in there. However, we do have some more advanced scripts in pm4py that you can use to query all kinds of basic statistics in your event log that we will cover in a separate tutorial. So thanks for watching, and I hope to see you in the next tutorial.